Let's talk about high availability features found in the Cisco Catalyst 9000 switching platform. Cisco has something that is known as the High Availability Strategic Circle that goes from design to management to network resiliency, that means using stack-wise, virtual or graceful insertion and removal, for instance, to system resiliency, that means using more than one supervisor or having redundant fans and power supplies. Operation resiliency, that means using Cisco features such as in-service software upgrades, extended fast software upgrades, hot patching, and this is a circle. So this is a summary of the features found in the Cisco Catalyst 9000. Stack-wise, think of up to 8 devices here. Stack-wise virtual, think of up to 2 devices here. You also have a stateful switchover with this line of switches. You can have NSF or NSR. When using NSF, the neighbors become aware that you're having a failover. With NSR, your neighbors are unaware that you're having a failover. With NSF, your adjacencies may go down. With NSR, your adjacencies remain up. With NSF, your neighbors will keep sending traffic. So that means that it requires collaboration from neighbors that are known as helpers. In NSR, the neighbor's assistance is not required. NSF is available for BGP, OSPF version 2 and FHRP. NSR is available for OSPF and OSPF v3 only. Use NSR if NSF is not the right fit for your network. You can also use the Cisco features such as in-service software upgrade that will upgrade an image on a device while the network continues to forward packets. It is supported on high availability scenarios such as having 2 supervisors or in an stack-wise virtual scenario. The extended fast software upgrade will keep data forwarding across switch reloads. The graceful insertion and removal will isolate a switch from the network so you can work with it, and it will put it in a maintenance mode, and in this mode this device will be removed actually from the network. It will not participate in network traffic. You can also have loop-free IP fast reroute feature that works for OSPF and GRP when you have some new options to transition to backup routes if a link fails. You can also have the quad supervisor feature where you can actually work with 4 supervisors if you have a stack-wise virtual where each chassis has 2 supervisors. Remember that the benefits of a stack-wise virtual are that you will eliminate the need for a spanning tree protocol, fixed hop redundancy protocol, you will have more bandwidth using multi-chassis ether channel, and you will leverage the usage of stateful switchover and NSF. So for SSO, remember that there are SSO aware applications that are mainly layer 2 features and protocols, and SSO compliant applications that are usually layer 3 protocols and features. And if you're going to use in-service software upgrade, you can see the status of an upgrade with this command, or you can execute it using a 1-step approach or a 3-step approach. When using graceful insertion and removal, you first optionally will create a template, then you will set up your maintenance mode, setting a timeout and which template you will use. You can use a default template, and then you can start with your maintenance using this command that will remove your device from the network, and then after you have worked with it, you can issue this command to bring back your device to the network. In order to configure non-stop forwarding, you have this command for OSPF, this for FHRP, or for this for BGP. You can configure non-stop routing, for instance, for OSPF this way. You can use extended fast software upgrades for this catalyst. This will protect traffic that belongs to these features and protocols. Remember that extended fast software upgrade will help you keeping traffic moving even in the event of having to reload a switch due to an upgrade. This is the way that you will execute it. In order to use fast reroute, you can use commands like this for OSPF. Remember that this series of catalysts supports the use of x86 CPU, so you can run Docker-based container application, for instance, for anything you want to use or for orchestration. This Docker environment is isolated from the switch resources. Remember that these switches use UADP ASICs. These are the foundation of the Catalyst 9000 series. These ASICs are actually what do or what performs the data plane forwarding. These are several versions of these ASICs, and you will find them depending on the actual switch that you will be using. And depending on the platform, you will get one CPU and several amount of these chips. And in order to see how these chips are interacting with your operating system, use the command show platform software or show platform hardware. That's it.